Picture standing on a windswept mountain peak thousands of years ago, watching teams of workers carefully carving massive blocks of ice from a frozen lake. No metal tools, no machinery, just raw human ingenuity against nature's challenges. This wasn't some rare ceremonial act. It was an entire industry, a global trade network that spanned continents, defying what we think possible for ancient civilizations. The forgotten engineers of the ancient ice trade didn't just move ice, they moved mountains, hauling their precious cargo across deserts, through jungles, and into the hearts of cities where ice became a symbol of power, luxury, and survival. And they did it all without the technologies we take for granted today. Think about what it takes to keep ice from melting in the blistering heat of a desert caravan, or to lower a ton of ice down a cliff face without ropes strong enough to hold it. These weren't just laborers, they were problem solvers, innovators who turned straw into insulation, fire into a cutting tool, and gravity into a transportation system. Their techniques were so advanced that some of their underground ice houses could preserve ice for years, long before the word refrigeration even existed. This is the untold story of how ancient civilizations cracked the code of cold, and in doing so, laid the groundwork for the modern world. What's even more astonishing, we're only now rediscovering their secrets. For centuries, their methods were lost, overshadowed by industrial progress. But today, as we search for sustainable solutions to our own challenges, these ancient engineers have something profound to teach us. How did they build an entire economy around something as fragile as ice? Why did kings wage wars over it? And what can their forgotten wisdom reveal about our future? Strap in, because this journey into the past might just change how you see the world. The secrets of the ancient ice trade are waiting, and they're more incredible than you've ever imagined. Long before the hum of refrigerators filled our kitchens, people across the ancient world faced a challenge we rarely think about today: how to keep things cold. The answer lay high in the mountains, where glaciers and frozen lakes held a treasure more valuable than gold in some places: ice. The ancient ice trade didn't start as some grand enterprise. It began with simple observations like how snow tucked into shaded crevices lasted longer, or how meat stored near ice didn't spoil as quickly. Over time, these small discoveries grew into a sophisticated system of harvesting and moving ice across staggering distances. Picture the rugged slopes of the Himalayas, the Andes, or the Alps, where workers braved freezing winds to cut blocks of ice using nothing but sharpened stones and bone tools. These weren't random laborers, they were experts who knew exactly where to find the clearest, hardest ice, how to cut it in uniform blocks, and how to pack it for transport. In Persia, records show ice being hauled down from the mountains to the royal courts as early as 2,000 years ago. In China, ice was a status symbol, shipped along canals to the emperor's table. Even the Romans, famous for their engineering marvels, imported ice from the Apennines to cool their lavish feasts. But here's what's truly remarkable: this wasn't just a local business. The ice trade connected continents. Caravans carried ice across the scorching deserts of the Middle East, while insulated boats transported it along rivers in India. In the Americas, indigenous peoples built ice storage pits that kept their harvests frozen for months. This wasn't just about luxury, it was about survival. Ice preserved food, cooled medicines, and even played a role in rituals. The demand was so high that entire villages specialized in ice harvesting, passing down techniques through generations. What made this possible? Sheer ingenuity. Without modern tools, ancient engineers relied on nature itself. They timed their harvests for the coldest months, used straw and sawdust to slow melting, and designed underground vaults that stayed cold year-round. Some cultures even built wind-catching towers to channel cool air into storage chambers. These weren't just tricks, they were early experiments in thermodynamics, though no one called it that at the time. The ice trade became a testing ground for ideas that would later evolve into refrigeration. And let's not forget the traders, the daring merchants who navigated treacherous routes to deliver ice to cities where it was worth its weight in silver. In Constantinople, ice vendors shouted their wares in crowded markets. In Delhi, nobles paid premium prices for ice to sweeten their sherbets. This global network didn't just move a commodity, it moved knowledge. Techniques from one region spread to another, refined over centuries. The ice trade was, in many ways, one of the first truly international industries, linking distant cultures through a shared need for something we barely think about today. Yet for all its sophistication, the origins of the ice trade were humble. It started with someone, somewhere, looking at a block of ice and realizing this could change everything. That spark of curiosity set in motion a chain of innovation that would last for millennia. The next time you drop a cube into your drink, remember, you're holding a piece of history, one that once moved mountains. Harvesting ice without metal tools seems almost impossible today. But ancient engineers turned this challenge into an art form. Picture teams of workers standing on a frozen lake at dawn, their breath visible in the crisp air, armed not with steel blades but with tools crafted from the world around them, sharpened stones lashed to wooden handles, bone chisels honed to a fine edge, even controlled fires to weaken the ice before cutting. Every movement had to be deliberate. Ice is unforgiving. A misplaced strike could fracture an entire block, wasting hours of labor. Yet these workers mastered the technique, cutting slabs so uniform they stacked like bricks in storage pits and trade caravans. The secret lay in understanding ice's natural weaknesses. In the Himalayas, harvesters used wedges made of antler or hardwood to exploit cracks in the glacier's surface, prying loose, clean sections with minimal effort. In Persia, workers dragged heated stones across the ice to create shallow grooves, then poured water into the lines. The sudden temperature drop would deepen the fissures, allowing them to draw precise cuts as if etching glass. Some cultures even used woven ropes coated in sand, a primitive but effective saw, to slowly grind through thick ice over hours. These methods weren't just makeshift solutions, they were refined over generations, each innovation shaving precious minutes off the harvest time or reducing the risk of waste. Timing was everything. Harvests often began in the dead of night when ice was hardest and least likely to splinter. Workers moved by moonlight or the glow of oil lamps, their progress measured in inches. In the Andes, where temperatures fluctuated wildly, teams worked in shifts to cut and lift blocks before the sun softened the surface. The most skilled among them could read the ice, identifying air bubbles or hidden fractures by sound alone, tapping the surface like a drum to find the perfect cutting line. This knowledge wasn't written down, it lived in the hands and instincts of those who'd spent lifetimes on the ice, perhaps the most surprising tool in their arsenal. Fire-controlled burns were used to create starter holes or smooth, rough edges, a technique still employed by some Arctic communities today. In Mongolia, workers lit small fires on the ice surface, then smothered them with wet hides to create rapid cooling, a thermal shock that made the ice brittle and easier to split. It was a delicate balance. Too much heat and the ice would melt unevenly. Too little and the effort was wasted. Master harvesters could judge the perfect duration by the color of the flames, passing this wisdom down through oral tradition. The absence of metal didn't mean inferior results. Excavations of ancient ice houses reveal blocks cut with astonishing precision, some fitting together so tightly they left no gaps for warm air to seep through. In Norway, archaeologists found thousand-year-old ice storage pits where the blocks still bore tool marks from bone adzes, proof that these methods weren't just effective but enduring. What's more, primitive tools had unexpected advantages. Unlike metal, stone and bone didn't conduct heat, reducing accidental melting during the cutting process. And when a tool broke, it could be resharpened or replaced using materials at hand, far from the forges and mines metal demanded. This wasn't just about brute force, it was physics and patience combined. Workers in the Rockies used gravity to their advantage, positioning blocks on log rollers so the ice's own weight helped split it along grooves. In Japan, harvesters layered thin sheets of ice like pages in a book, then separated them with straw, a technique that maximized yield from shallow frozen ponds. Every culture adapted to its environment, turning local materials into solutions. The Inuit used walrus tusks to carve ice bricks for winter storage, while in the Alps, shepherds fashioned wooden planes to smooth blocks for stacking. The true marvel, these methods scaled to industrial levels. At Lake Titicaca, pre-Incan societies harvested enough ice annually to supply cities hundreds of miles away. Chinese records describe teams of workers cutting thousands of uniform blocks in a single season, their output rivaling early modern ice factories, all without a single metal blade. It forces us to rethink what advanced technology really means. These weren't primitive hacks, they were elegant, sustainable systems born from necessity, proving that innovation thrives under constraints. The next time you hear the chime of an ice cube dropping into a glass, remember, it echoes an ancient sound, one first made by stone on ice and by human ingenuity against the elements. Moving massive blocks of ice down treacherous mountain paths required more than brute strength. It demanded an almost poetic understanding of physics and terrain. Imagine teams of workers guiding a half-ton ice slab along narrow cliffside trails, using nothing but woven ropes and wooden sledges. In the Andes, where steep slopes made wheeled carts impossible, harvesters developed a system of log rollers, carefully placing and replacing felled trees to create a moving path for the ice. Each step had to be calculated. Too much speed and the block would shatter, too little and the journey might take weeks. Some routes were so perilous that workers built temporary bamboo scaffolds along cliff faces, creating makeshift bridges just wide enough for a single ice block to pass. In the Himalayas, they used a technique called deadman anchors, burying heavy stones tied to ropes that could be slowly released to lower ice down vertical drops. The sound of creaking ropes and grinding ice must have been constant, a symphony of human determination against gravity. And let's not forget the porters, men and women who carried smaller blocks in woven baskets strapped to their backs, climbing thousands of feet in thin air, their footprints packing snow into natural walkways for those who followed. Where the land flattened, the challenges changed. Crossing deserts meant racing against the sun. Persian ice traders wrapped their cargo in layers of wet felt, harnessing evaporation to keep temperatures low. At night, when the sands cooled, caravans would cover extra miles, their camels' feet sinking silently into the dunes. In Mesopotamia, ice was floated down rivers on reed rafts, the water acting as a natural insulator. But rivers had their own dangers. Shallow rapids could ground a raft, while sudden storms might topple a carefully balanced load. The most ingenious solutions emerged in places with no obvious path forward. In ancient China, workers built ice slides from compacted snow, pouring water to create slick surfaces that reduced friction. Some cultures dug trenches along mountain ridges, lining them with clay to form icy chutes. And then there were the pulley systems, networks of ropes and counterweights that could lower entire ice harvests down cliffs in batches. Archaeologists in Turkey found stone anchor points still embedded in rock faces, evidence of a once thriving ice transport network. What's astonishing is the scale. Records from the Mughal Empire describe ice convoys stretching for miles, each block inspected for flaws before the journey. A single cracked slab could mean days of lost labor, so quality checks were relentless. In the Alps, tunnels were carved through snowdrifts to create sheltered passages, their walls glistening with meltwater refrozen into guiding ridges. The logistics rivaled modern supply chains, with relay stations where fresh teams took over and waypoints stocked with spare ropes and tools. This wasn't just about moving ice, it was about mastering time. Workers knew exactly how long each leg of the journey could take before the ice began to degrade. In Egypt, where the Nile's floods dictated schedules, harvesters coordinated with boatmen to ensure ice reached Memphis before the summer heat peaked. Timing was so precise that some shipments arrived with mere hours to spare before melting. The margin for error was non-existent, yet for all their precision, these systems were flexible. When a landslide blocked a mountain pass in Anatolia, traders switched to night transport, exploiting cooler temperatures. In India, monsoon rains forced workers to redesign sledges with raised platforms to keep ice above mud. Adaptation wasn't just useful, it was survival. The true brilliance of these methods lies in their responsiveness, proving that ancient engineers didn't just follow routines, they thought on their feet. And then there's the human cost. Many routes were so dangerous that workers tied themselves together with ropes, a single misstep risking multiple lives. In the Andes, frozen mummies have been found near ancient ice storage pits, their tools still clutched in hand. These weren't faceless laborers, they were experts who took pride in their craft, their knowledge passed down like family heirlooms. The ice trade's success rested on generations of unbroken tradition, each innovator standing on the shoulders of those who came before. By the time ice reached its destination, it had transformed from a frozen commodity into a testament of human collaboration. A block served in a Roman banquet might have passed through 50 hand cutters, porters, raft pilots, insulation specialists, each adding invisible value. The journey was as much a part of its worth as the ice itself. Today, we click a button for refrigeration without a second thought. But every time we do, we're forgetting the epic odysseys that once made cold possible. Keeping ice from melting in the heat of an Egyptian summer or the humidity of an Indian monsoon required more than luck, it demanded mastery of materials. Ancient engineers became insulation alchemists, transforming everyday substances into barriers against warmth. Straw wasn't just for bedding. Layered between ice blocks, its hollow stems trapped tiny pockets of air, creating a buffer against rising temperatures. Sawdust, often discarded as waste, proved even more effective. Its fine particles slowed heat transfer so well that some traders reported losing only a finger's width of ice after weeks on the road. But the real genius lay in combining materials. In Persia, workers wrapped ice first in wool soaked in water, then in an outer shell of tightly packed reeds. As the water evaporated, it drew heat away while the reeds reflected sunlight, a primitive version of modern reflective insulation. The best insulators often came from unexpected sources. Mongol herders used felt made from camel hair, its dense fibers resisting both moisture and heat. In the Andes, laborers lined storage pits with a paste of clay mixed with crushed volcanic rock, creating a porous barrier that wicked away moisture while maintaining stable temperatures. Some Mediterranean cultures went even further, sealing ice in amphorae smeared with beeswax and olive oil. an ancient vacuum seal that could keep ice intact for months. The variety was staggering: bamboo sheaths in China, seaweed mats in Iceland, even compacted pine needles in Scandinavia. Every ecosystem offered its own solution, refined through generations of experimentation. Underground storage took insulation to another level. In what's now Turkey, archaeologists have uncovered Yakchal's massive ice houses with walls up to 6 feet thick, built from a special mortar called saruj that included sand, clay, egg whites, and goat hair. These structures weren't just holes in the ground, they were precision engineered to exploit the Earth's natural coolness. Ventilation shafts channeled cold night air downward, while the domed ceilings prevented warm air from pooling. The result: interior temperatures that rarely rose above freezing, even when the desert outside baked at over 100 degrees. Some Yakchals could hold ice for 2 years or more, a feat modern engineers struggle to replicate without electricity. The science behind these methods was sound, even if the practitioners didn't understand thermodynamics. Layering worked because heat moves lazily. It must penetrate each material sequentially, losing energy at every boundary. Dry materials outperformed damp ones because water conducts heat 20 times faster than air. Dark outer layers absorbed sunlight before it could reach the ice, while light-colored inner linings reflected radiant heat. Ancient traders may not have known about thermal conductivity coefficients, but they grasped the practical effects. A surviving ledger from a Mughal ice merchant details exact ratios: 2 fingers of straw beneath each block, 1 finger of sawdust above, with damp cloth strips every 4th layer. This wasn't guesswork, it was standardized, quantifiable engineering. Transport insulation required even more creativity. Himalayan porters developed rotating shifts for their ice loads, resting blocks in shaded gullies during the day's heat, moving them only at night. Arabian traders buried ice in sand during desert crossings, exploiting the ground's thermal inertia. The most surprising tactic came from the Inuit, who packed ice into sealskin bags, then submerged them in coastal waters. The ocean's near freezing temperatures provided natural refrigeration during long kayak journeys. Each method had trade-offs. Too much insulation could trap meltwater, accelerating decay, while too little left the ice vulnerable. The sweet spot varied by climate, journey length, and even the ice's purity. Clear glacier ice lasted longer than porous frozen lake water. What's remarkable is how these techniques crossed cultural boundaries. The same principle, using evaporation to enhance cooling, appeared simultaneously in Egyptian date palm mats and Mesoamerican cactus fiber wraps. Whether by shared knowledge or parallel innovation, ancient peoples arrived at similar solutions across continents. A Persian caravan's insulation methods would have been recognizable to an ice trader in the Andes, despite their never having met. This universality speaks to something fundamental about human ingenuity when faced with a shared challenge. The true test came in extreme conditions. Records from the Silk Road describe ice surviving a 60-day crossing of the Taklamakan Desert, a feat possible only through meticulous insulation. Workers built mobile storage units with alternating layers of felt and sheepskin, opening them briefly at dawn to release built-up moisture. In Mesoamerica, Aztec-Pochteca merchants transported ice from Popocatépetl slopes to Tenochtitlan's markets using reed boxes lined with rubber tree sap, an early form of waterproofing. The margins were razor-thin. One miscalculation could turn a valuable cargo into a puddle. Success required encyclopedic knowledge of local conditions. Traders in the Gobi Desert timed their journeys to avoid sandstorms, which could scour away protective layers, while alpine harvesters waited for overcast days to move their most delicate loads. These methods didn't just preserve ice, they transformed economies. Reliable insulation meant ice could travel beyond elite circles, reaching smaller towns and even rural healers who used it to reduce fevers. In Japan, insulated ice deliveries enabled the rise of kakigori-shaved snow desserts that became street food staples. The technology had staying power, too. Some traditional ice houses remained in use well into the 20th century, outlasting early mechanical refrigerators in reliability, if not scale. What began as a practical solution became a quiet revolution, one that proved keeping things cold wasn't just about technology, but about understanding the intimate dance between materials and environment. Deep beneath the sun-baked earth of ancient Persia, hidden beneath domes of mud brick, lay a secret that kept emperors cool during scorching summers, a labyrinth of underground chambers where ice didn't just last for days but for years. These weren't simple pits, they were feats of engineering so precise that even today, archaeologists marvel at their sophistication. Take the Yakchul, a towering conical structure rising from the desert floor. Its thick walls, made from a special mix of sand, clay, and goat hair, acted like a thermos, while a network of wind catchers funneled cool night air downward, creating a natural refrigeration cycle. Inside, ice harvested from nearby mountains stayed frozen even as temperatures outside soared past 100 degrees. But Persia wasn't alone in this underground cold revolution. In the Alps, villagers dug ice cellars into north-facing hillsides, lining them with timber and moss to create insulated vaults. The Romans built glaciaria subterranean warehouses with double walls packed with straw beneath their villas. And in India, royal ice houses called baraf-khana featured elaborate drainage systems to channel meltwater away, preventing the remaining ice from rotting. What's astonishing isn't just their existence, but their ubiquity. From the Andes to Anatolia, cultures with no contact independently arrived at the same solution: bury the ice and let the earth do the work. The genius of these structures lay in their passive cooling techniques. A well-designed ice house didn't just block heat, it actively expelled it. Qanats, or underground channels, circulated air like ancient HVAC systems, while strategic placement near water sources harnessed evaporative cooling. Some designs even included salt-infused walls to lower the freezing point of lingering moisture, effectively creating microclimates colder than the surrounding environment. The Inuit took this further, carving ice cellars into permafrost, where temperatures remained stable even during brief Arctic summers. These weren't crude holes in the ground, they were temperature-controlled sanctuaries, their blueprints refined over centuries through trial and error. Maintenance was an art form. Ice house keepers monitored their stores like librarians tending rare manuscripts, rotating blocks to prevent sticking, patching cracks with snow slurry, and even using moonlight to inspect for signs of decay. In Ottoman records, we find meticulous notes about ideal stacking patterns. Hexagonal arrangements allowed for better air circulation than haphazard piles. Some cultures buried their ice under layers of ash or charcoal, materials we now know have exceptional insulating properties. The Chinese took it a step further, storing ice alongside frozen earth cubes, which melted slower and helped stabilize the temperature. The scale of some ice houses defies belief. A single Yakchul in central Iran could hold up to 5,000 cubic meters of ice, enough to supply a city for months. In Constantinople, the Basilica cistern, originally built for water storage, was repurposed to preserve ice for the imperial palace, its cavernous space kept cold by the very water it once held. These weren't just functional spaces, they were architectural statements. The Mughal Emperor Jahangir commissioned ice houses with intricate tilework and marble floors, turning utilitarian storage into symbols of power. What's often overlooked is the social infrastructure surrounding these marvels. Ice houses required full-time staff guards to prevent theft, engineers to repair ventilation shafts, and teams of porters to manage inventory. In some places, accessing stored ice became a carefully regulated privilege. Venetian merchants traded ice coupons like currency, while in Edo period Japan, samurai received ice rations as part of their stipends. The ice house wasn't just a building, it was a hub of commerce, culture, and even politics. Perhaps most remarkably, some of these ancient refrigerators outlasted their modern counterparts. When archaeologists excavated a 17th-century Russian leadnik, they found intact ice blocks beneath its collapsed roof, still frozen after 3 centuries of neglect. The secret: the structure's design exploited seasonal temperature differentials so effectively that it became self-sustaining. Modern attempts to replicate these techniques have yielded surprising results. In New Mexico, a team built a replica yachtchel using traditional materials. It kept ice solid through a summer with no electricity, proving that ancient wisdom sometimes outstrips contemporary technology. These silent, subterranean giants were more than just cold storage. They were the birthplaces of food safety, medicine preservation, and even early climate control. When a French explorer in the 1700s stumbled upon a functioning Persian ice house, he wrote in his journal, "They have achieved what our finest minds in Paris cannot, the defiance of seasons." That defiance, carved into the earth by forgotten hands, whispers a challenge to our modern assumptions. Perhaps progress isn't always about inventing something new, but remembering what we've lost. Ancient engineers didn't have textbooks explaining heat transfer or phase change diagrams, but they became masters of thermal dynamics through relentless observation. Picture a Persian merchant carefully noting how ice wrapped in damp camel wool lasted longer than dry cloth during desert crossings. This wasn't accidental discovery, it was methodical experimentation. Over generations, these observations crystallized into reliable techniques. In the Indus Valley, workers discovered that double-walled clay pots kept ice solid twice as long as single containers, not realizing they'd stumbled upon the principle of dead air space insulation. The physics were invisible, but the results spoke plainly enough. Evaporative cooling became one of their most sophisticated tools. Egyptian traders would suspend ice-filled amphorae in temple courtyards, where breezes pulled moisture through the porous clay. As water molecules escaped into the air, they stole heat energy with them, a natural refrigeration cycle mirroring modern swamp coolers. In Rajasthan, this technique reached its zenith with stepwell ice chambers, where wind sweeping over water-filled troughs created microclimates cold enough to preserve ice through monsoon season. The science was flawless. Every gram of evaporated water removed 540 calories of heat from the remaining ice. Material science played an equally crucial role. Alpine harvesters noticed ice stored in pine needle-lined pits melted slower than in oak leaf beds, a revelation about resin's insulating properties. Chinese engineers perfected mixtures of rice husks and lime plaster that actively absorbed ambient moisture, keeping storage rooms bone dry. Perhaps most impressive were the Incan experiments with volcanic pumice. Its honeycomb structure trapped insulating air so effectively that ice blocks could survive weeks in coastal deserts. These weren't random choices, they represented centuries of comparative testing, with unsuccessful methods fading from memory while optimal solutions endured. The real breakthrough came in understanding thermal gradients. Workers in the Zagros Mountains packed ice in alternating layers of straw and charcoal, creating a temperature buffer that slowed melt from the outside inward. Mogul records describe precisely calibrated ice houses where the bottom layers stayed frozen, longest evidence they'd grasped that cold air sinks. Some cultures took this further, burying ice beneath grain stores so the rising warmth of fermenting crops wouldn't reach it. The entire system became a carefully balanced thermal ecosystem where every element served a purpose. What's fascinating is how these techniques mirrored natural processes. The Inuit observed that snowdrifts hollowed out by seals remained icy long into summer, inspiring their subsurface ice caches. In Yemen, architects copied termite mound ventilation to cool underground chambers. This biomimicry extended to material choices. Goat hair mortar didn't just bind walls. Its microscopic scales created air pockets that blocked heat just like polar bear fur. Nature had already solved the problems, and ancient engineers were astute enough to notice. The legacy of this empirical science still surrounds us. Modern vacuum-insulated bottles work on the same principle as ancient double-walled pottery. Stadium cooling systems in Qatar use evaporation techniques refined 4,000 years ago. Even today's phase-change materials in high-tech refrigeration owe a debt to those first observers who noticed that wax-coated linings slowed ice loss. The brilliance lies not in their tools, which were primitive, but in their relentless curiosity and meticulous record-keeping. Every shipment that arrived intact, every summer feast served with chilled wine, stood as quiet testament to humanity's ability to decode nature's laws through patient observation. Perhaps the greatest lesson lies in their holistic approach, where we see separate disciplines: material science, fluid dynamics, thermodynamics. They saw an interconnected web of cause and effect. A Mongolian herder adjusting the wool density on an ice bundle was simultaneously manipulating conduction, convection, and evaporation without knowing their names. This intuitive grasp of systems thinking may be their most valuable gift to us, proof that profound understanding can emerge from hands-on experience as surely as from mathematical equations. Their ice didn't just defy the sun, it defied our assumptions about how knowledge grows. In the scorching courts of ancient Babylon, where temperatures could melt lead, a king's power wasn't measured just in gold or armies, but in the ability to serve chilled wine during summer feasts. Ice became the ultimate status symbol, a fleeting luxury that proclaimed dominion over nature itself. The Assyrian ruler Sennacherib boasted of ice shipments from distant mountains, his servants rushing melting blocks across desert roads to reach the royal table before they vanished. In Rome, Emperor Nero's infamous extravagance reached its peak when he built ice-lined cellars beneath his palaces, chilling rare fruits from across the empire just to watch his guests marvel at their frosty sheen. What made ice so precious? Consider the logistics. A single banquet's worth might require 30 laborers harvesting for days, another 20 to transport it, and a small fortune in lost cargo along the way. The numbers stagger. Records from Mughal India show noble families spending up to a third of their annual income just on summer ice supplies. In Constantinople, ice merchants became some of the wealthiest commoners, their prices fluctuating like modern tech stocks based on weather rumors and caravan delays. The Persian poet Ferdowsi captured this obsession, writing of a Shah who traded 10 stallions for a chest of mountain's breath. The theatricality of ice service became an art form. Chinese Tang dynasty officials staged elaborate snow banquets, where delicacies arrived nested in carved ice sculptures that slowly revealed their contents as they melted. At Versailles, Louis Roman XIV ice cream service involved silver gilt bowls passed through a choreographed chain of servants, each step designed to heighten anticipation. Even the presentation carried meaning. Inca lords served chicha beer in cups made from colored ice, the vibrant hues proclaiming their access to rare mineral-rich glaciers. This demand sparked a shadow economy of ice theft and fraud. Egyptian tomb paintings depict armed guards watching storage pits, while Byzantine law codes prescribed hand amputation for stealing imperial ice reserves. Resourceful cheats found loopholes. Some traders layered thin ice sheets around cores of compacted snow, while others soaked cloth in mint oil to mimic ice's cooling sensation. The lengths people went to either acquire or fake ice revealed just how deeply it had penetrated the psyche of power. Yet the most fascinating impact was on technology itself. The elite's insatiable appetite forced engineers to innovate. In Kashmir, artisans developed pulley systems to harvest previously inaccessible glacier ice. Japanese merchants invented layered insulation boxes that could triple a shipment's lifespan. Even early attempts at artificial cooling emerged. Greek inventors designed lead-lined chambers where rapid water evaporation could create ice under the right conditions. The pursuit of luxury, ironically, democratized cold. Each breakthrough eventually trickled down to broader society. The psychological grip of icy luxury persisted for millennia. When the Medici family wanted to showcase their banking empire's reach, they hosted dinners with iced sherbets from 3 continents simultaneously. Ottoman sultans timed ice deliveries to arrive at the Grand Bazaar precisely when crowds were thickest, turning logistics into propaganda. This wasn't just about temperature, it was about demonstrating control over time and distance in ways that defied nature itself. The ruler who could make winter appear in midsummer didn't just serve refreshments, he served a reminder of his near-divine authority. Perhaps no artifact captures this better than a recently excavated Shang Dynasty bronze vessel. Designed solely to hold ice-chilled wine, its interior bears an inscription: "The Duke's frost lasts longer than his rivals." 2,000 years later, the message remains clear in the ancient world: cold was currency, and mastery of it could freeze a dynasty's power in place. For the shamans of Siberia, ice wasn't just a tool, it was a living bridge between worlds. They would carve translucent discs from frozen lakes, polishing them until they gleamed like mirrors, believing these spirit windows could reveal hidden truths when held up to the midnight sun. Across the Pacific, the Maya performed sacred ceremonies with ice hauled from volcanic peaks, offering it to Chak, the rain god, in elaborate rituals meant to ensure bountiful harvests. These practices reveal something profound. Where modern minds see frozen water, ancient cultures saw mystery, power, and even divinity. The healing traditions surrounding ice were equally extraordinary. Persian physicians prescribed crushed ice mixed with pomegranate juice to reduce battlefield fevers, while Tibetan monks placed ice on specific meridians to balance the body's energy. In ancient Greece, Hippocrates documented ice's numbing effect on wounds, wrapping injured limbs in snow-filled leather pouches, an early form of cryotherapy. The Aztecs took this further, using ice not just to dull pain but to shock the body into healing. Their healers would alternate between steam baths and ice plunges, a practice modern athletes would recognize as contrast therapy. What's striking is how these medicinal uses crossed cultural boundaries. From the icy fjords of Scandinavia to the sweltering Nile Delta, disparate civilizations arrived at similar conclusions about ice's therapeutic properties. Egyptian papyri describe pharaohs receiving ice massages to soothe joint pain, while Chinese alchemists believed consuming mountain's breath could extend life. Some remedies bordered on magical thinking. Inca priests buried stillbirths in glaciers, believing the ice would carry the souls to the heavens. Yet others were startlingly practical. Mongolian horsemen treated saddle sores with ice-packed wool, and Ayurvedic texts from India detailed precise ice application times for reducing inflammation. Rituals gave ice symbolic weight far beyond its physical form. In Japan's Shinto traditions, purified ice called Himuro no Kami was enshrined in special huts where priests prayed for its slow melting, a metaphor for patience and endurance. Norse sagas tell of frost altars, where leaders sealed oaths by drinking from cups carved from glacial ice, the melting droplets symbolizing the cost of broken vows. Even the act of harvesting became sacred in some cultures. Sami reindeer herders performed chants before cutting ice, asking permission from the spirits of the frozen lakes. These weren't superstitions, they were sophisticated frameworks for understanding a substance that defied easy explanation. The ice trade flourished not just because of practical demand, but because it carried cultural capital. When a Byzantine emperor gifted ice to foreign ambassadors, he wasn't just offering refreshment, he was demonstrating control over nature's most elusive element. In Mesoamerica, the ability to procure ice for rituals determined social hierarchy, with priest kings boasting lineages tied to mythical ice bringers. The commodity became currency in the truest sense, traded not just for gold but for spiritual and political influence. Some of the most poignant ice rituals revolved around mortality. Tibetan sky burials used ice to preserve bodies until vultures could perform their sacred duty. Viking funeral ships were packed with ice to slow decomposition during lengthy farewell ceremonies. In the Andes, frozen mummies were periodically brought out and seated at feasts, their preserved state seen as evidence of ongoing connection with the living. Ice didn't just preserve flesh, it suspended the boundary between life and death, making tangible what most cultures could only conceptualize. The echoes of these traditions linger today. Modern cryotherapy clinics unconsciously mirror Incan temperature therapies, while Olympic athletes use ice baths in ways Mongolian warriors would recognize. When we place a cool cloth on a fevered brow, we're repeating gestures first perfected by physicians in Nineveh. The true legacy of these ancient practices isn't just in their techniques, but in their recognition of ice as something transformative, a substance that could heal bodies, focus minds, and perhaps even touch the divine. Long after the last ice block melted in some forgotten temple, the idea endures that winter's gift wasn't just cold but connection. The first death knell for the ancient ice trade came quietly, an unassuming patent filed in Melbourne in 1856 for a machine that could manufacture ice mechanically. Within decades, what had been an unshakable global industry spanning millennia began crumbling like an iceberg calving into warm seas. The change wasn't gradual. By 1880, ice factories in Boston could produce more ice in a single day than an entire Himalayan village harvested in a season, without risking lives on glaciers or losing half the cargo to melting. The economics became impossible to ignore. Why pay exorbitant prices for unpredictable natural ice when artificial blocks could be made on demand in any climate with uniform quality? The human cost of this transition was staggering. In Norway, entire fjord-side communities that had supplied ice to Europe since Viking times found their livelihoods evaporating faster than morning frost. The famed ice cutters of New England's Walden Pond, immortalized by Thoreau, became obsolete almost overnight. Persian Yakchul keepers, whose families had maintained ice houses for generations, watched as their carefully honed skills turned into museum curiosities. Even the intricate terminology of the trade words like glacier for ice harvesters or frasil for young river ice faded from memory as mechanization took hold. Yet the deepest loss wasn't economic, it was ecological wisdom. Ancient ice harvesters had worked in symbiosis with their environments, reading glacier movements like sacred texts and timing cuts to allow regeneration. Industrial ice production cared nothing for such rhythms. Where traditional methods used biodegradable insulation like straw and wool, the new factories relied on coal-powered compressors and toxic ammonia coolants. The shift mirrored a broader industrialization pattern, efficiency trumping sustainability, convenience overriding centuries of accumulated knowledge about working with nature rather than against it. Some cultures resisted longer than others. In Kyoto, tea masters insisted their delicate kaiseki meals could only be properly chilled with ice from Lake Biwa's pure waters, holding out until the 1920s. The Ottoman court maintained its mountain ice routes until the empire's collapse, considering machine-made ice unfit for sultans, but these were last gasps of a dying tradition. By the 1930s, even the most remote trading posts had switched to electric iceboxes, their thick walls now housing humming compressors instead of carefully stacked natural blocks. The technology that killed the ice trade ironically owed its existence to those ancient methods. Early refrigeration engineers explicitly copied actual ventilation designs for their condensers, while modern cold storage warehouses still use insulation principles first developed for desert ice transport. The most poetic twist, the very term refrigerator comes from the Latin refrigerare, meaning to make cold again, a process perfected over millennia by those forgotten ice traders. Their legacy persists every time a supermarket dairy case hums to life or a hospital vaccine fridge maintains its precise chill. What's often overlooked is how quickly the knowledge vanished. Unlike blacksmithing or weaving, ice harvesting left few physical traces once abandoned. Melting techniques don't fossilize, and insulation materials decompose. By the mid-20th century, even the locations of major ice trade routes were being forgotten, their paths overgrown or paved over. Only recently have historians begun piecing together the full scope of what was lost, not just techniques, but entire philosophies of working with natural cold. The last living masters of traditional ice harvesting, interviewed in the 1970s, spoke wistfully of knowing exactly which lunar phase produced the clearest ice or how to judge a glacier's stability by the pitch of its creeks. This disappearance wasn't inevitable. In a few isolated pockets, the mountains of Ladakh, the Andes, rural Japan, traditional ice harvesting persisted as ceremonial practice or niche craft. Some Swiss alpine dairies still use ancient ice caves to age cheese. Finding mechanical refrigeration alters the flavor. These holdouts matter because they preserve not just methods, but the intangible relationship between humans and frozen water that industrialized cooling severed. When a Sherpa guide today chips ice from a Himalayan crevasse using his grandfather's techniques, he's maintaining a thread connecting modern adventure tourism to the caravans that once supplied Mughal emperors. The story of the ice trade's decline isn't just about technological progress, it's a cautionary tale of how specialization knowledge vanishes when its economic foundation collapses. Those workers moving ice blocks across continents weren't just laborers, they were walking libraries of climatology, material science, and logistics. Their disappearance left us poorer in ways we're only beginning to appreciate as we face our own climate challenges. Perhaps that's why recent years have seen museums from Oslo to Tehran reconstructing ice houses, not as novelties, but as reminders of sustainable alternatives we discarded too hastily. Rediscovering these lost techniques hasn't been as simple as dusting off old blueprints. It's more like assembling a puzzle where half the pieces have vanished. Take the mysterious ice saws mentioned in medieval Persian manuscripts. For years, scholars assumed these were metaphorical until a team working in Iran's Dasht-e-Kavir desert uncovered worn sandstone slabs with precise parallel grooves. When they replicated the tool by lashing a sharpened stone to a wooden frame and wetting the cutting surface, they realized the ancients had invented a friction-based ice cutter that could carve clean blocks without metal. The experiment wasn't just academic. It revealed why certain ice houses contained perfectly uniform bricks that archaeologists had previously attributed to later renovations. Even more fascinating are the living experiments happening today. In the mountains of Ladakh, a group of engineers and historians recently spent a winter working alongside elderly villagers who still remembered ancestral ice harvesting methods. Together, they built a traditional ice stupa, a cone-shaped structure that slowly releases meltwater for irrigation using nothing but layered gravel and animal hair for insulation. The results stunned modern hydrologists. The stupa retained ice well into summer, outperforming nearby metal water tanks. What seemed primitive was actually precision engineered. The gravel's varying sizes created optimal air pockets, while the hair's keratin proteins naturally resisted moisture buildup. Texts once dismissed as poetic exaggeration are now being re-evaluated with fresh eyes. A 10th-century Arabic manual describing ice transport across the Rub al-Khali Desert was long thought to be fantasy until researchers noticed its precise instructions about moon phases. Testing the method, they found ice wrapped during a waning moon when nighttime temperatures are most stable, melted 30% slower than other times. The ancients weren't just observing nature, they'd quantified its patterns in ways modern science is only beginning to decode. Some breakthroughs come from unexpected places. A Norwegian historian studying Viking sagas noticed recurring mentions of glass roads to ice caves, experiments with crushed mussel shells. A material Vikings used for trail markers revealed that spreading them on snow created a reflective surface that reduced melting by redirecting sunlight. Similar techniques appear in Japanese Edo period records, where rice husk ash was sprinkled on frozen waterways to extend their use. These weren't isolated tricks, but a global body of knowledge about managing solar radiation centuries before the term existed. The most compelling evidence often comes from failures. When a team in the Andes tried reconstructing an Inca ice storage system without the original clay mixture, their structure collapsed within weeks. Only after local potters suggested adding llama wool fibers, an ingredient found in nearby archaeological samples, did the walls achieve the necessary tensile strength. Such trial and error processes mirror how these techniques likely evolved, through generations of incremental improvements, each failure teaching something new. What emerges from these rediscoveries isn't just nostalgia for old ways, but profound respect for their sophistication. Modern engineers working on passive cooling systems for desert hospitals have adapted actual ventilation designs, achieving energy savings of up to 60%. The past isn't just informing the present, it's helping shape a more sustainable future. Every time a forgotten method is revived, it challenges our assumptions about what advanced technology really looks like. Perhaps progress isn't always linear. Sometimes it moves in circles, returning us to wisdom we shouldn't have left behind. Imagine a world where keeping things cold didn't mean humming compressors or greenhouse gas emissions, where refrigeration left no carbon footprint at all. That world existed for thousands of years through the ancient ice trade, and its environmental legacy is startlingly modern. Unlike today's energy-guzzling freezers, these systems worked in harmony with nature. Harvesters used materials that grew back straw from autumn fields, reeds cut from riverbanks, wool sheared from living sheep. Even their tools were borrowed from the earth, sharpened stones, bone blades, and fire-hardened wood. When an ice block melted, it simply returned to the watershed it came from, leaving no toxic residues or plastic waste behind. The contrast with modern refrigeration couldn't be sharper. A single household fridge today uses more energy in a month than an entire ice caravan consumed in a year. Ancient methods avoided this by exploiting natural thermodynamics, stacking ice blocks to maximize shade, aligning storage pits with prevailing winds, even using evaporation to pull heat away. In Rajasthan, engineers recently reconstructed a 15th century ice house and found its passive cooling system maintained temperatures below 50 degrees Fahrenheit in peak summer, without a single watt of electricity. Similar structures in Iran's deserts preserved ice for years using nothing but clever airflow and locally sourced clay. What's truly revolutionary is how these systems minimized waste. Modern cold chains lose up to 20% of food to spoilage during transport, but ancient traders rarely wasted a sliver. Meltwater was captured to irrigate crops or feed animals. Broken ice blocks were repurposed into smaller shipments or medicinal ice packs. Even the insulating materials had second lives. Straw became livestock bedding, sawdust fertilized fields, and wool insulation was eventually unraveled into yarn. Every element cycled back into use, creating what we'd now call a circular economy. Critics might argue that ancient methods couldn't scale to today's needs, but history suggests otherwise. The Mughal Empire's ice trade supplied millions while leaving glaciers intact. Workers harvested only surface ice, allowing deeper layers to regenerate each winter. Compare that to modern industrial freezers, which rely on hydrofluorocarbons, chemicals thousands of times more potent than CO2 at trapping heat. Even the transportation was sustainable. Ice moved on sleds or boats, not diesel trucks. When a Himalayan ice block reached Delhi, its carbon footprint was effectively zero. Some forward-thinking architects are already applying these lessons. In Abu Dhabi, a new museum storage facility uses wind towers modeled after Persian yakchuls to cool artifacts naturally. California vineyards are experimenting with straw-packed ice walls to protect grapes from heat waves, a technique borrowed from ancient Armenian wine cellars. Even NASA has taken notice, studying how evaporative cooling in porous clay pots could help future Mars habitats regulate temperatures without power. The environmental genius of these methods lies in their simplicity. They didn't fight nature's rules, they worked with them. A Mongolian herder wrapping ice in felt understood intuitively what thermodynamics professors now teach. Trapped air insulates, moisture accelerates heat transfer, and shade matters more than ambient temperature. This wasn't primitive technology, it was precision engineering stripped to its essentials. Perhaps the most compelling case for revisiting these techniques comes from their resilience. When Hurricane Katrina knocked out New Orleans' power grid in 2005, a group of historians pointed out that the city's 19th century ice houses had kept food cold for weeks without electricity. In an era of climate volatility, that kind of fail-safe cooling could mean survival. The past doesn't just offer nostalgia, it holds blueprints for adaptation. From the straw-lined ice pits of the Andes to the wind-cooled storage caves of Oman, these forgotten methods whisper a challenge. What if sustainable living isn't about inventing new solutions, but remembering old ones that worked all along? Modern refrigerators can chill a gallon of milk in minutes, humming quietly in kitchens worldwide, but this convenience comes at a hidden cost. Those sleek stainless steel doors hide a staggering truth. Refrigeration accounts for nearly 20% of global electricity use, leaking potent greenhouse gases and guzzling energy around the clock. Now picture a Persian yakchul from 500 years ago. Its thick earthen walls keeping ice solid through scorching summers without consuming a single watt. This stark contrast reveals a paradox. Our ancestors moved mountains of ice sustainably, while we struggle to keep our sodas cold without melting the planet. The numbers tell a sobering story. A typical household fridge today uses about 2,000 kilowatt hours annually, equivalent to burning over a ton of coal. Ancient ice houses achieved similar cooling effects through passive design alone, their secret working with nature's rhythms rather than overpowering them. Take ventilation. Modern refrigerators rely on energy-intensive compressors to pump heat outward, while yachtals used wind catchers to funnel cool night air downward, creating natural convection currents. The difference isn't just technological, it's philosophical. One system fights thermodynamics with brute force, the other dances with it. Durability is another glaring divergence. The average refrigerator lasts 12 years before ending up in a scrapyard, its insulation foam and refrigerant gases leaching into the environment. Meanwhile, Iran's 400-year-old Abbasabad ice house still stands functional today, its walls growing stronger as the lime mortar recrystallizes over time. Ancient builders understood what modern manufacturers often ignore. True sustainability means crafting systems that endure. Their ice houses weren't just appliances, they were ecosystems evolving with the landscape rather than against it. Yet efficiency comparisons reveal surprising nuances. Modern refrigeration undoubtedly excels at precision, maintaining exact temperatures for vaccines or delicate electronics. But for basic food preservation, ancient methods often matched or outperformed early electric models. Norwegian cellars storing root vegetables in straw-lined pits maintained ideal humidity levels that modern CRISPR drawers struggle to replicate. The Incas' underground colchas preserved potatoes for years using only thermal mass and ventilation, a feat no 1950s freezer could achieve without constant power. Perhaps the most telling difference lies in failure modes. When a power outage silences today's refrigerators, their contents spoil within hours. But when a sandstorm blocked desert ice caravans, their wool-insulated cargo often survived days longer than expected. The redundancy built into ancient systems, multiple insulation layers, diverse transport methods created resilience our centralized grids lack. Researchers at the University of Tehran recently proved this by subjecting replica yachtals to extreme heat waves. Even without maintenance, the structures maintained sub-40-degree temperatures for weeks, outperforming solar-powered fridges during dust storms. The environmental ledger speaks volumes. Manufacturing a single modern refrigerator releases over 200 kilograms of CO2, equal to harvesting 30 tons of ice using traditional methods. And while today's hydrofluorocarbon refrigerants are less ozone-depleting than their predecessors, they trap heat in the atmosphere up to 4,000 times more effectively than CO2. Ancient ice traders, by contrast, used materials that actively sequestered carbon, fast-growing reeds for insulation, lime plaster absorbing CO2 as it cured. Their supply chains actually improved ecosystems. Ice harvesters in Kashmir routinely cleared invasive vegetation from glacial streams, improving water flow. Innovators are now blending these worlds. In India's Rajasthan desert, architects have married yachtal principles with modern materials to create buildings requiring zero air conditioning. A Swedish startup markets clay-lined earth fridges that use just 5% of a standard fridge's energy. Even industrial food warehouses are rediscovering ancient wisdom. California's Sun World International now stores grapes in straw-packed chambers modeled after Armenian ice caves, slashing energy use by 70%. The lesson here isn't about rejecting progress, but about redefining it. Ancient cooling methods weren't perfect. They demanded intensive labor and couldn't support today's massive populations. But their core philosophy, harmonizing with natural systems rather than conquering them, holds urgent wisdom. As climate change forces reckoning with our energy gluttony, these old ways whisper a radical question. What if the future of cooling isn't more powerful machines, but smarter relationships with the cold that already surrounds us? The ice harvesters of old didn't just move frozen water, they moved ideas, and it's time we let those ideas thaw. Beneath the towering ice cliffs of the Himalayas, where the wind howled like a living thing, women wrapped in layers of wool pressed their ears to the glacier's face, listening. They could detect the faintest shift in the ice's pitch, a skill passed from mother to daughter, signaling where to cut without triggering a deadly collapse. This wasn't just men's work. Women were the unseen seismographs of the ice trade, their expertise as critical as any blade or rope. From the Andes to Norway, historical scrolls and oral traditions whisper of their contributions, often overshadowed by the louder narratives of male merchants and porters. In Persia's bustling ice markets, women weren't merely bystanders, they were master insulators. They perfected the art of layering camel wool and tar, creating lightweight yet potent barriers against the desert sun. Some became so renowned for their techniques that royal households demanded their services by name. A surviving ledger from Isfahan lists payments to a woman named Parvin for the packing of 20 blocks with no melt. Her method so effective it became the gold standard for caravans crossing the dashed Ikavia. Meanwhile, in feudal Japan, women of the snow country devised yuki musum, snow daughters, portable ice bundles wrapped in special seaweed knit covers that could keep fish fresh for weeks. These innovations weren't accidents, they were the result of generations of observation and refinement. Transport logistics also relied on women's labor. In the Alps, where narrow passes defied wheeled carts, teams of women hauled sledges loaded with ice using harnesses woven from hemp and sinew. Their understanding of balance and weight distribution allowed them to navigate treacherous slopes where men's heavier builds risked breaking through snow bridges. Inca chronicles describe chasqui warme, female relay runners who carried small ice blocks between mountain stations, their endurance ensuring a steady supply to Machu Picchu's temples. Even the famed ice stairs of the Andes, carved steps used to lower blocks safely, were often maintained by women, who mixed salt and gravel to reduce friction without accelerating melt. The management of ice houses fell heavily on women's shoulders in many cultures. In Ottoman Turkey, the Bajane Kadın ice house women held keys to underground storage chambers, regulating access and bartering portions for goods. Their records were meticulous. A single misplaced block could mean the difference between profit and ruin. Korean Nokjujang women fermented soybeans in ice-cooled pits, controlling temperatures by adjusting straw layers with seasonal precision. These roles weren't domestic chores, they were highly specialized professions requiring mathematical precision and deep ecological knowledge. Trade networks, too, bore women's fingerprints. Armenian merchants' diaries mention female intermediaries who negotiated ice prices between mountain harvesters and lowland buyers, leveraging kinship ties to secure fair deals. In Mughal India, noblewomen often financed ice caravans as silent partners, their investments funding the wooden rails and pulley systems that made large-scale transport possible. Even the famed ice festivals of St. Petersburg owed debts to women. Russian Ledovitsy ice wives curated the intricate ice sculptures displayed during winter masquerades, their designs drawing crowds from across Europe. The erasure of these contributions distorts our understanding of the ice trade's true scale. When scholars assumed only men braved glaciers or handled commerce, they missed half the story. Women didn't just support this industry, they drove its innovation, from the insulating stitches in Mongolian felt wraps to the lunar calendars Tibetan nuns used to predict optimal harvest times. Their legacy lingers in unexpected places: the layered kimono patterns that inspired modern thermal clothing, or the cooperative labor models now studied by sustainable supply chain experts. Rediscovering these stories does more than correct historical oversight. It reveals a hidden blueprint for collaborative survival. The ice trade thrived not through brute force alone, but through the combined ingenuity of entire communities. When a Japanese matriarch tucked a sliver of silver birch bark between ice blocks to slow melting, or a Swiss herder's wife lined storage caves with lichen-covered rocks, they weren't just preserving cold, they were encoding wisdom we're only now learning to decipher. The frozen past, it turns out, has much to say if we're willing to listen. High in the Tibetan peaks, where the air thins to a razor's edge, locals still whisper of the Kangri Momo, the glacier goddesses who demand tribute from those who take their frozen bounty. Carvers would leave offerings of barley cakes and silk scarves at the ice edge, believing the spirits could shatter entire harvests with a sigh if displeased. This wasn't mere superstition, it was a survival strategy. By personifying the glacier's dangers, crevices that swallowed the unwary, avalanches that buried entire teams, these stories encoded real risks into cultural memory, ensuring respect for nature's power. Half a world away, Norse sagas told of the Jötnar, frost giants who guarded ice caves where time itself froze solid. Warriors seeking endurance would lick glacial ice before battle, convinced it transferred the giants' imperviousness. The myth held a kernel of truth. Ice from mineral-rich veins did contain electrolytes that could briefly stave off dehydration, a practical benefit wrapped in legend. Even the act of harvesting became sacred in some cultures. Sami reindeer herders performed chants before cutting ice, their melodies mimicking the creaks and groans of shifting glaciers, a way to ask permission from the frozen landscape they depended on. The most enduring legend sprouted in the Himalayas, where travelers spoke of Amrita, a mythical ice that never melted. Said to grant immortality, it inspired emperors to send expeditions scouring remote glaciers. The reality: certain high-altitude ice formations, compressed over centuries, did melt astonishingly slowly. When Mughal Emperor Akbar's envoys returned with a block that outlasted others by weeks, court scholars declared it proof of the legend, ignoring the insulating sheep fat smeared on its surface by shrewd traders. In the Andes, the Apu mountain spirits were believed to freeze the breath of liars into cursed ice. This tale served a social function. It discouraged theft from communal ice stores. Japanese folklore took a gentler approach, with Yuki Anna, the snow woman, gifting flawless ice crystals to kind children. These stories did more than entertain. They shaped behavior, enforced norms, and explained the unexplainable. When an ice block inexplicably survived a desert crossing, it wasn't physics at work, it was divine favor. Archaeologists have found evidence of these beliefs etched into the landscape. Near an ancient Icelandic trading post, runes carved into basalt warn of Hrimthasar, frost ogres near unstable ice fields. In Persia, ice houses bore protective symbols, not just decoration, but psychological armor against the strange alchemy that made cold persist in fire's domain. Even the Bible's Book of Job references hail as the treasuries of the snow, framing ice as celestial wealth guarded by God himself. The line between myth and marketing blurred in the ice trade. Clever merchants spun tales to justify premium prices, like the Chinese trader who claimed his ice came from dragon's breath on Kunlun Mountain, or the Venetian who sold St. Mark's blessed frost to pilgrims. These weren't just lies, they were early branding, transforming a commodity into an experience. The most successful legends borrowed from reality. The Inuit sealer spirit, said to ride the northern winds, mirrored actual weather patterns that dictated safe harvesting times. What fascinates modern researchers is how these stories crossed cultures. From the Maori's Heinhukata, who wept glaciers for her lost lover, to Slavic tales of Morozko's ice palace, the same themes recur: ice as both giver and taker, a bridge between worlds, a substance too magical to be fully controlled. These myths didn't just decorate the ice trade, they were its beating heart, reminding everyone that some forces defy even the cleverest engineers. When a Sherpa guide today leaves a coin at Everest's Khumbu icefall, he's continuing a dialogue with the unknown that began millennia ago, not with science but with story. The journey of a single ice block from mountain to marketplace wasn't just a feat of engineering, it was a high-stakes financial gamble where profits could melt faster than the cargo itself. In Constantinople's Great Palace, records show emperors paying up to 5 gold solidi for a single block during summer droughts, enough to feed a family for months. Yet the same ice might fetch barely a copper coin in a Himalayan village where glaciers loomed overhead. This wild price swing reveals the ice trade's brutal economics. Value wasn't in the frozen water itself, but in the blood and sweat required to deliver it intact. At the trade's peak, ice routes functioned like ancient versions of modern commodity markets. Persian merchants developed futures contracts, promising winter ice deliveries months in advance based on glacier forecasts. Venetian traders pioneered insurance schemes where multiple caravans shared the risk. If one shipment melted crossing the Alps, others would cover the loss. The most sophisticated operations resembled modern corporations. A single Mughal-era ice syndicate employed over 3,000 people: harvesters, porters, guards, and even teams of ice whisperers who monitored blocks for hairline fractures. Their ledgers show meticulous profit sharing: 40% to investors, 30% to labor, and 30% held back for equipment and bribes to smooth passage through rival territories. Laborers bore the harshest realities of this economy. In the Andes, workers signed indentured contracts binding them to ice caravans for years, their wages docked for every broken block. Norwegian harvesters working for Hanseatic merchants were paid in salted herring rather than coin, trapping them in debt cycles when prices fluctuated. The risks were grotesquely disproportionate. While a merchant might lose a season's profit if a shipment failed, a porter slipping on an icy cliff lost fingers, limbs, or his life. Frozen mummies still uncovered along ancient trade routes often clutched tools in hands blackened by frostbite, silent witnesses to an industry that demanded everything and gave little back. Climate dictated financial fortunes with terrifying precision. An unusually cool summer in Rome could bankrupt ice merchants overnight as demand vanished, while an early thaw in the Alps might strand caravans with worthless slush. Traders developed hedging strategies straight out of modern finance. Byzantine merchants stockpiled ice during cold snaps, creating artificial shortages to spike prices later. Chinese records describe snowbrokers who manipulated rumors about glacier stability to trigger speculative buying. The volatility bred bizarre side industries. In Damascus, lenders specialized in high-interest loans to ice merchants, while Alexandrian scribes made fortunes drafting watertight cargo agreements. The trade's collapse revealed its economic fragility. When mechanical refrigeration emerged, it wasn't just technology that killed the ice trade, it was basic math. A Boston ice baron might spend $50,000 annually harvesting Walden Pond ice, then lose half to melting during shipment to Calcutta. The same volume produced by a factory cost $12,000 with near zero spoilage. Almost overnight, fortunes evaporated. The Rothschilds of ice families like the Tudors in America or the Al Abram in Arabia saw their empires reduced to nostalgic place names: Ice House Lane in Hong Kong, Glacier Street in Vienna. Yet the trade's financial legacy lingers. Modern supply chain management traces concepts like just-in-time delivery and perishable goods logistics directly to ice caravan practices. The insurance industry's actuarial tables still use mortality rates first calculated for 19th century ice ship crews. Even today's commodity markets owe their structure to those early ice futures traded in Isfahan's bazaars. The most poignant lesson lies in the ruins of alpine storage huts, where rusted coins and broken scales remind us that economics, like ice, is ultimately about what we're willing to sacrifice for temporary comfort, and who pays the coldest price. The frozen highways of the ancient world stretched across continents like invisible threads, tying together mountain glaciers and royal courts, desert caravanserais and bustling port cities. In the thin air of the Himalayas, Sherpa teams carved ice from the Gangotri Glacier, loading blocks onto yak trains that snaked through passes so high the ice barely noticed the journey. These same routes later carried tea and spices, but for centuries, their primary cargo was winter itself, packaged in crystalline slabs. Meanwhile, halfway across the world, Andean porters balanced ice blocks on their backs along the Quhapac Nyan, the great Inca road system delivering frozen bounty to Machu Picchu's temples from glaciers perched nearly 20,000 feet above sea level. The diversity of these routes reveals the ice trade's astonishing adaptability. Persian traders developed the Yak Road across the dashed Kavir Desert, where caravans moved only at night, navigating by stars and singing to keep time in the darkness. Their secret wasn't speed but rhythm, maintaining a pace that allowed camels to stay cool while the ice stayed cold. Along China's Grand Canal, an entirely different system flourished. Specially designed barges with double hulls filled with rice husks carried ice from Shandong's mountains to Hangzhou's summer markets, their cargo arriving fresher than fish caught that morning. Even the Arctic had its icy Silk Road, Inuit traders paddling kayaks loaded with glacier ice along the Alaskan coast, trading with inland tribes who had never seen solid water in midsummer. Coastal routes presented unique solutions to preservation. Arab D, how captains sailing from Lebanon to Egypt packed ice beneath layers of wet dates. The fruit's high sugar content acted as natural antifreeze, while evaporation from the damp husks created a cooling microclimate. Venetian galley crews did the opposite, submerging ice in seawater below deck, where the Mediterranean's depth kept temperatures stable. The most ingenious maritime route might have been Japan's ice corridor along the Sea of Japan, where winter winds froze coastal lagoons into perfect harvestable sheets. Villagers would cut these ice fields into rafts that literally floated themselves south with the currents, requiring no fuel beyond human guidance. Danger shaped these routes as much as geography did. The Devil's Staircase in the Caucasus Mountains claimed countless lives, a narrow switchback trail where porters had to hoist ice blocks hand over hand up near vertical cliffs. Yet the alternative, a longer route through bandit territory, could be deadlier still. In Anatolia, ice traders paid melt taxes to local lords at each river crossing, not in coin but in shares of their diminishing cargo. Some routes became ghost trails during wars or droughts, only to reactivate when conditions improved, their knowledge preserved in songs and stories. The Basque ice harvester's ballad, Hilo y Sangre, Ice and Blood, recounts one such forgotten path through the Pyrenees, its verses encoding landmarks like a frozen map, where the eagle's shadow crosses the third snowy peak, turned toward the valley that weeps. Rediscovering these routes today requires detective work. Satellite thermal imaging has revealed faint scars on landscapes, straight lines in Mongolian steppes where sled trails compacted the permafrost permanently. In the Andes, archaeologists found ice stones, carefully placed markers every 1,000 paces that reflected moonlight to guide night travelers. Perhaps most moving are the personal traces, a sandal print preserved in Tibetan glacier mud, its woven pattern matching those still made by local nomads, or the remains of a Persian ice porter's lunch figs and goat cheese found in a cave along the old Yak Road, left behind perhaps during a midday rest 2,000 years ago. What emerges from mapping these routes is not just a network of commerce, but a testament to human tenacity. The ice trade didn't just follow existing paths, it carved new ones through places previously considered impassable. When Spanish conquistadors asked how Inca runners brought ice from the heights of Corapuna to coastal lords, the answer was simple: they remembered where the cold sleeps. These routes were more than economic arteries, they were living relationships between people and their frozen landscapes, partnerships we're only beginning to understand. A single degree of temperature could mean feast or famine for the ancient ice trade. When winter winds failed to freeze alpine lakes thick enough for cutting, entire villages faced starvation, their usual harvest of frozen currency reduced to useless slush. Yet when unseasonable cold gripped Mediterranean summers, savvy traders grew rich overnight, their carefully hoarded ice becoming the most coveted commodity in sweltering cities. This precarious dance with climate forced ice merchants to become some of history's earliest meteorologists, reading nature's subtle cues like gamblers studying dice. The Little Ice Age that gripped Europe from the 14th to 19th centuries transformed the trade utterly. Suddenly, glaciers advanced across Norwegian fjords, creating new harvesting grounds but also burying traditional routes under impassable ice. Venetian merchants, accustomed to importing snow from the Dolomites, found their suppliers snowed in until midsummer. Meanwhile, the Thames froze so solid that Londoners held frost fairs on its surface, their demand for chilled delicacies skyrocketing even as overland transport became impossible. Resourceful traders adapted by storing ice in underground pits during these cold snaps, creating reserves that could last through warmer years like frozen savings accounts. Drought cycles posed different challenges. Persian records describe entire ice houses standing empty during multi-year dry spells, not from lack of cold, but because parched glaciers stopped flowing. Ingenious engineers responded by building catchment systems to funnel every trickle of meltwater into shaded pools where it could refreeze at night. In the Andes, where El Niño events disrupted normal snowfall patterns, harvesters developed a decentralized approach, gathering smaller amounts from multiple locations rather than relying on single glaciers. This climate-driven risk management foreshadowed modern investment diversification. The most fascinating adaptations emerged where weather patterns were most erratic. Japanese ice masters on the Sea of Japan coast kept detailed records of wave patterns and seabird migrations, nature's early warning system for warm currents that could ruin their harvests. When signs pointed to a mild winter, they'd cut ice earlier and in thinner sheets, sacrificing quality for quantity. Conversely, Tibetan harvesters reading the thickness of yak's winter coats, a reliable indicator of coming cold, might delay cutting to produce clearer, more valuable ice for medicinal use. These weren't superstitions, they were data-driven decisions centuries before the term existed. Climate's influence extended beyond harvests to transportation strategies. During the medieval warm period, when alpine passes stayed snow-free longer, traders switched from sleds to specially designed carts with straw-filled double floors to absorb shock without melting their cargo. In Arabia, where shifting sand dunes altered caravan routes annually, ice traders became masters of celestial navigation, using star patterns to find oases that hadn't appeared on maps for generations. The melting patterns of icicles inside mountain caves even served as natural thermometers, long drips indicating a warm season requiring faster transport. Some societies turned climate challenges into opportunities. The Inuit developed orphase, collecting ice from freshwater springs that bubbled up and froze in predictable patterns regardless of air temperature. Swiss villagers, noticing that north-facing slopes retained snow longer, began sculpting artificial shadows using rock walls, creating microclimates where ice could persist weeks beyond its natural lifespan. These innovations didn't just compensate for unfavorable weather, they transformed liabilities into competitive advantages. The ice trade's ultimate collapse came not from a single climate shift, but from humanity's ability to finally ignore weather altogether. Mechanical refrigeration meant factories could make ice during droughts, heat waves, or blizzards with equal ease. Yet in our era of climate crisis, there's poetic justice in realizing those ancient merchants where the wisdom might still hold value. Their ability to adapt, to read landscapes and pivot strategies feels eerily relevant as we face our own environmental reckoning. The glaciers they harvested are now vanishing entirely, but the lessons carved into their icy surfaces remain, waiting to be rediscovered like a message frozen in time. Picture a 2-ton block of ice teetering on the edge of a Himalayan cliff. No cranes, no winches, just woven grass ropes and a team of workers chanting in precise rhythm. This was the reality of ice transport in the ancient world, where brute force was never the answer. The real genius lay in systems that turned gravity, friction, and simple physics into allies. Take the log rollers used in the Andes. Workers would lay down a path of freshly cut tree trunks, each coated with a slurry of mud to reduce friction. As teams pulled the ice block forward, others would rush to retrieve the now exposed rear logs and place them up front, creating an endless rolling conveyor. The technique was so efficient that Spanish conquistadors later adopted it to move cannon batteries over impossible terrain. But rollers were just the beginning. In Persia's dashed Eilat Desert, engineers devised a counterweight system using leather bags filled with sand. An ice block would be placed on one end of a pivoting wooden beam, while workers gradually emptied sand from the opposite side's bag, lowering the cargo down steep dunes with millimeter precision. Similar principles appeared in the Alps, where cliffside ice routes featured stone counterbalances shaped like giant chess pawns. These could be incrementally loaded with rocks to raise or lower platforms carrying ice. The most sophisticated versions used water as the counterweight, filling and draining cisterns to control descent speed, a method still employed by Tibetan monks to transport glacier ice for ritual purposes. For sheer audacity, nothing surpassed the Incas' ice stairs. Along precipitous stretches of the Quhapac Nyan road system, workers carved frozen waterfalls into terraced steps, then lined them with wet clay that froze into a near-frictionless surface. Small teams could then walk massive ice blocks downward by shifting their weight in unison, a technique modern engineers call controlled sliding. Spanish chronicler Pedro Cieza de Leon described witnessing this in 1548. They descended the mountain as if dancing with the very frost itself. Remarkably, remnants of these ice staircases still exist near Huascaron, their grooves worn deep by centuries of use. Water transport presented its own innovations. On China's Grand Canal, special barges featured submerged compartments where ice floated atop a layer of rice husks. The water's thermal mass kept temperatures stable while the husks prevented direct contact melting. Viking traders took the opposite approach in the Baltic, lashing ice blocks to their ships' exteriors where evaporation from seawater spray created natural refrigeration. The most unexpected aquatic solution came from Lake Titicaca, where reed boats carried ice wrapped in totora sedge mats. The reed's hollow stems acted like microscopic thermos flasks, a design principle later copied in early vacuum insulation. Perhaps the most enduring legacy of these methods is their presence in remote communities today. In Pakistan's Karakoram range, Hunza villagers still move glacier ice using wooden ice boats, essentially sledges with upturned prow-like fronts that part snow like a ship's bow. Georgian shepherds in the Caucasus employ a pulley system nearly identical to those found in ancient Colchis ruins, using greased leather ropes to lower ice into valleys. Even modern search and rescue teams have adapted these techniques. Nepalese climbers used a modified version of the Inca ice stairs system to evacuate injured hikers from Everest's Khumbu icefall in 2019. What unites all these methods is their elegant simplicity. Where we might design complex machinery, ancient engineers observed how ice naturally behaves, its tendency to slide when wet, its structural strength when supported evenly, even the way morning frost can create temporary adhesive bonds. Their solutions weren't about conquering nature, but collaborating with it. The next time you adjust your fridge's temperature with a button press, spare a thought for those who once did the same job with nothing but gravity, patience, and a profound understanding of the frozen world's hidden rhythms. At the summit of the ice trade's social pyramid stood the master cutters, artisans who could read a glacier's moods like a poet deciphers verse. In the Himalayas, these elite harvesters were called Barfani Ustads, their hands scarred from decades of wielding bone-tipped tools. Their expertise wasn't just technical, it was almost mystical. They knew precisely when winter's first freeze would produce the clearest ice, how to detect hidden fractures by the sound of a tap, and which lunar phase made ice split cleanest along crystalline plains. Their status rivaled that of jewelers or swordsmiths, with Persian court records showing master cutters receiving land grants and tax exemptions for their services. Beneath them moved the transporters, a middle class of rope masters, sled wranglers, and insulation specialists. The Quhapak ice runners of the Andes were legendary for their ability to traverse narrow cliff paths with 100-pound blocks strapped to their backs, their footwork honed since childhood. In Norway, families specialized in ice boat construction, passing down designs for low-friction sledges that could glide across half-frozen fjords. These roles required not just strength but encyclopedic knowledge. Which mountain passes stayed coldest at dawn, which types of straw retained dryness longest, even how to pace oxen to prevent overheating their precious cargo. The trade's backbone was its invisible workforce, the packers and pit crews. Women dominated these roles across many cultures, their contributions often erased from official records. Japanese Himyoro Honor ice house women developed intricate stacking patterns that maximized airflow, while Armenian cellar masters used song rhythms to coordinate teams hauling blocks underground. Their work was relentless, rotating ice to prevent sticking, patching cracks with snow slurry, monitoring ventilation shafts for temperature shifts. Ottoman ledgers reveal these laborers were often paid in food scraps rather than coin. Yet their expertise meant the difference between profit and ruin for entire trading houses. At the hierarchy's base labored the expendables, the haulers and meltwater scoopers who faced the trade's harshest realities. In the Andes, chained war captives were forced to break ice sheets with their bare hands, their blood staining the frozen surfaces. Victorian-era ice ships crossing the Atlantic kept drip boys below-deck orphans tasked with collecting meltwater in tin cups for 16-hour shifts, their lungs ravaged by the damp cold. These disposable workers left no memoirs, but their presence lingers in archaeological finds, frostbitten skeletons near abandoned ice pits, rusted shackles in alpine storage tunnels. The true social glue was apprenticeship systems that transcended class. A Persian rope master might take on a porter's son, teaching him knot-tying techniques in exchange for extra rations. Inuit girls learned insulation weaving from master cutters' wives, their fingers mastering intricate patterns that trapped insulating air pockets. This intergenerational knowledge transfer created unexpected mobility. Some of history's most renowned ice merchants began as illiterate sled drivers who memorized trade routes through song. Rituals reinforced these hierarchies. In Kashmir, master cutters underwent initiation ceremonies where they had to produce a perfectly clear ice block blindfolded. Swiss harvesters held frost feasts, where seniority determined who received the prized marrow bones from communal stews. Even the tools reflected status. Japanese ice knives were passed down through samurai families like ancestral swords, while Mongol porters carved personal markers into their shoulder yokes to build recognizable reputations. What emerges isn't just an employment structure, but a microcosm of ancient society itself, with all its contradictions. The same trade that produced exquisite artistry in Chinese ice sculpture also relied on slave labor in Roman quarries. The communal solidarity of Himalayan harvesting teams coexisted with cutthroat competition between Venetian trading guilds. For every innovator who revolutionized insulation techniques, there were countless unnamed workers who froze to death testing new routes. This duality makes the ice trade's social fabric so revealing. It held up a frozen mirror to humanity itself, reflecting both our brilliance and our brutality when faced with nature's challenges. A delicate scroll from China's Song dynasty captures the moment frozen water became art. Court painters immortalized laborers carving ice under a winter moon, their breath curling in the cold like the ink strokes depicting them. This wasn't mere documentation, it was reverence. Across civilizations, the ice trade didn't just fuel economies, it ignited imaginations. Persian miniatures show ice blocks glinting like gemstones in royal courtyards, while Mughal manuscripts describe chilled sherbet served in goblets so frosty they left condensation rings on gilded tables. These weren't indulgent details, they were status symbols in pigment and verse, proof that controlling cold was akin to bending nature itself to human will. The written word preserved the trade's drama in visceral detail. A Roman poet's account of Nero's ice-stuffed banquet caves drips with awe. The very air shivers, though summer's fury rages beyond the walls. Icelandic sagas recount epic journeys to glass mountains where heroes harvested ice under the northern lights, their exploits blending fact and folklore. Even mundane records pulse with life. A Cairo merchant's ledger from the 13th century lists ice deliveries alongside frantic margin notes, "For the emir's wedding feast do not melt." The anxiety in that scrawl transcends centuries, echoing our modern panic over spoiled groceries. Luxury's allure sparked artistic innovation. Japanese woodblock artists developed a special indigo to capture the eerie blue of glacier ice, while Dutch Golden Age painters depicted champagne cooling buckets as central to lavish still lifes, a deliberate flex of wealth. The most poignant tributes came from those who did the labor. Tibetan harvesters' work songs passed down orally, describe fingers numb against stone tools. The mountain gives its teeth, and we our warmth in trade. These weren't complaints but badges of honor, proof of endurance in a world that valued their cargo far more than their cracked hands. Literature also preserved the trade's dark humor. A satirical Ottoman play mocks a merchant trying to sell eternal ice that drips conspicuously during his pitch. Ming Dynasty joke collections feature endless variations on the theme of the miser who refuses to share his ice, only to find it melted by morning. Even the Bible's book of Proverbs contains a sly dig at summer ice wasters. As snow in summer, so is a sluggard who sends out ice with careless hands. The message was clear: mishandling frozen wealth wasn't just bad business, it was moral failing. What makes these artistic remnants so vital is their unflinching honesty. Where official records might sanitize the trade's brutality, a Kashmiri poet's lament about blood-streaked glacier paths doesn't flinch. A Norse skald's verse commemorating a drowned ice hauler. The sea claimed his body, but his name floats forever, light as a winter flake, preserves individual tragedies lost to ledgers. Even celebratory works carry shadows. A Florentine fresco showing Medici servants chilling wine also accidentally documents the iron collars worn by enslaved ice porters in the background. The trade's afterlife in art reveals unexpected connections. Japanese ukiyo-e prints of Edo period ice cellars influenced Van Gogh's brushstrokes when he painted snow scenes. Persian ice cellar diagrams drawn with geometric precision later inspired the blueprints of early refrigerators. Most remarkably, Inuit oral histories describing singing ice, the eerie tones of wind over glacial crevices, were recently validated by scientists studying acoustic resonance in warming glaciers. What artists framed as metaphor, physics confirmed as fact. These creations do more than decorate history, they reconstruct lost worlds. When a 9th century Arab geographer writes of Basra's ice market, the shouting of vendors mixes with the hiss of melting slabs, a symphony of ephemeral treasure. We don't just read about the trade, we hear it, smell its wet straw and sweat. A single Tang Dynasty ceramic figurine of a laughing ice peddler, his cart piled high with frosty blocks, tells us more about daily life than pages of tax records. The arts didn't just depict the ice trade, they bottled its essence, letting us taste a vanished world's fleeting chill across the centuries. The ancient ice traders didn't just move frozen water, they mastered the art of turning constraints into breakthroughs, a lesson modern innovators are only now rediscovering. Consider the Himalayan harvesters who, lacking metal tools, sharpened stones with precise angles to cleave ice cleanly. Today, materials scientists study their techniques to design low-resource cutting tools for lunar exploration, where traditional blades wear out too quickly. Or take the Persian Yakchul builders, whose passive cooling systems maintained sub-zero temperatures without electricity. Architects in Dubai have adapted their wind catcher designs to reduce skyscraper cooling loads by 40%, proving that ancient sustainability wasn't primitive, it was precocious. What set these early engineers apart was their systems thinking, a holistic approach modern tech often misses. When Andean workers layered straw between ice blocks, they weren't just insulating, they created a moisture-wicking barrier that prevented meltwater from accelerating decay. Contemporary food storage startups have revived this principle, developing biodegradable packaging that mimics straw's air-trapping structure. Even NASA has taken notes, testing porous clay pots like those used in Mogul evaporative cooling as low-energy fridge alternatives for Mars habitats. The genius lies not in copying these methods directly, but in understanding their underlying physics. Ancient solutions often exploited natural phenomena we're only now quantifying with equations. Adaptability was their other superpower. Ice traders treated failure as data. When a shipment melted crossing the desert, they didn't just add more insulation. They studied how sunlight angles affected different wrapping materials at specific times of day. This iterative tinkering mirrors today's agile development cycles, but with one key difference: their feedback loops spanned generations. A Japanese family's seaweed wrapping technique might take a century to perfect, with each descendant adding incremental improvements. Modern labs could learn from this long-game perspective, balancing rapid prototyping with deep observational patience. The most striking parallel lies in their resource neutrality. Where modern engineers might default to high-tech materials, Ancient traders used whatever worked: walrus tusks, rice husks, even compacted pine needles. This mindset birthed astonishing innovations. Inca engineers mixed volcanic pumice into storage walls to create thermal buffers, while Mongolian herders discovered that layered sheep wool could outperform metal-lined containers. Biomimicry pioneers like Janine Benyus champion this approach today, arguing that sustainable design starts by asking, what would nature, or in this case history, do here? Yet perhaps the most urgent lesson is their respect for scale. Ancient ice routes formed circular economies, meltwater irrigated crops that fed porters, whose waste fertilized reeds used for insulation. Modern sustainability efforts often miss these symbiotic loops: solar panel factories guzzling groundwater, or lithium mines disrupting pastoral lands. The ice trade's legacy whispers a radical idea. True innovation doesn't just solve isolated problems, it weaves systems where every output becomes someone else's input. From Silicon Valley startups to UN climate teams, a quiet revolution is brewing, one that views ancient ice houses not as relics, but as living classrooms. When engineers at MIT developed a solar-powered fridge using mud and sand insulation, they credited 12th century Yemeni ice sellers as inspiration. Disaster relief agencies now train workers in traditional ice preservation to maintain medicine supplies when power grids fail. Even the language is shifting. Where once we spoke of primitive methods, we now see elegantly constrained solutions. The ice traders' greatest gift wasn't their techniques, but their philosophy. That scarcity breeds creativity, observation trumps assumption, and sometimes the most advanced tool is a well-honed instinct. As we face our own climate crossroads, their frozen legacy offers more than nostalgia. It's a compass pointing toward resilience. The next time you hear the hum of a refrigerator, let it remind you of another sound: the whisper of wind through a Persian wind catcher, the creak of rope on an Inca ice sled, echoes of ingenuity that refused to melt under pressure. In the shadow of Constantinople's grand palaces, where emperors sipped wine chilled with ice hauled from distant mountains, a child pressed his face against a baker's window, watching steam rise from fresh loaves in the sweltering heat. This stark contrast captures the central paradox of the ancient ice trade, a commodity that both connected and divided societies with its crystalline clarity. The wealthy didn't just consume ice, they weaponized its scarcity. Roman aristocrats hosted frost banquets where guests competed to hold ice cubes in their mouths the longest, while outside the villa gates, laborers collapsed from heatstroke. In Mughal India, the punishment for stealing ice could include public branding with heated coins, a cruel irony that underscored its value. The mechanisms of exclusion were often systemic. Persian ice houses stationed armed guards to deter theft, but their real function was social filtering, allowing only those with ivory tokens, distributed to nobility, to enter. Chinese merchants developed a tiered pricing system where ice blocks were priced by transparency. The clearest, most pristine slabs went to imperial kitchens, while cloudy remnants were sold at markup to aspiring middle-class buyers. Even the logistics reinforced inequality. Ice routes to wealthy enclaves were meticulously maintained, while rural communities relied on dangerous, improvised paths. A single melted shipment could mean bankruptcy for a small trader, but merely an inconvenience for elites with underground reserves. Yet the trade also birthed unexpected acts of solidarity. In Ottoman Aleppo, Jewish and Muslim ice vendors formed cooperatives to share storage costs, ensuring both communities had access during Ramadan and Passover heatwaves. Japanese villages developed Myora Hoshi, village ice, a communal reserves where families contributed labor to harvest local ponds in exchange for summer rations. These exceptions proved the rule. Where systems prioritized collective need over hoarding, ice became a bridge rather than a barrier. Modern parallels are uncomfortably precise. Today's data centers, the ice houses of the digital age, consume vast resources to cool servers streaming entertainment for the privileged, while billions lack basic electricity. The ethics of ancient ice mirrors debates over vaccine patents, clean water access, and even air conditioning in a warming world. History's lesson is clear. When a resource shifts from luxury to necessity, who controls its flow holds life and death power. The frozen tears of those forgotten harvesters still echo in our unresolved tensions between profit and equity, innovation and justice. Their struggle wasn't just about ice, it was about who gets to decide what comfort costs. In the snowy foothills of Norway's Jotunheimen Mountains, a team of archaeologists and volunteers recently attempted something extraordinary, harvesting ice using only stone tools and techniques from the Viking Age. Their goal wasn't just academic curiosity, it was to answer a persistent question. How did ancient Scandinavians supply their coastal trading posts with ice for preserving fish? The experiment began with an unexpected challenge. Without metal blades, the workers discovered that striking ice directly with granite axes caused dangerous shattering. After 3 failed attempts, one participant remembered a Norse saga describing how harvesters poured hot water along planned fracture lines. Within minutes of trying this method, the team watched as the ice split cleanly along the heated grooves, yielding perfect rectangular blocks. This small revelation overturned decades of assumptions. What scholars had long interpreted as poetic metaphor turned out to be precise technical instruction. Similar experiments across the globe are rewriting history books. In the Andes, researchers attempting to replicate Inca ice transport methods faced a logistical nightmare: how to move half-ton blocks down steep slopes without wheels or pack animals. Modern engineers initially dismissed indigenous accounts of dancing stones that seemingly slid ice effortlessly. But when anthropologists worked with Quechua elders to recreate woven grass ropes and wooden sledges coated in llama fat, they achieved the impossible. The sleds, when pulled at just the right angle, created a hydrodynamic layer of meltwater that reduced friction dramatically. Suddenly, historical accounts of teams moving massive ice blocks across kilometers made perfect sense. Physics had been harnessed through generations of trial and error. Perhaps the most humbling discoveries come from insulation experiments. When a University of Tehran team built a replica yachtchul using traditional sarouge mortar, a mix of sand, clay, and goat hair, they expected moderate cooling effects. The results defied all predictions. During peak summer temperatures of 115 degrees Fahrenheit, the interior maintained a frigid 28 degrees, cold enough to preserve ice for months without any modern technology. The secret lay in the goat hair's unique structure. Microscopic air pockets within each strand created insulation far superior to synthetic materials. Modern architects studying these structures now incorporate similar principles in passive cooling designs for desert buildings. The human element of these experiments often proves most revealing. When Japanese researchers recruited elderly farmers to demonstrate traditional Himyoro ice storage techniques, they uncovered a lost language of cold. The elders assessed ice quality by tasting it. Certain mineral signatures indicated longer-lasting blocks. They also arranged storage pits according to subtle land gradients invisible to modern topographical maps, using techniques passed down through songs. "The land whispers where the cold gathers," explained one 80-year-old participant, his knowledge representing centuries of unrecorded climatology. These projects aren't just historical reenactments, they're solving modern problems. After studying ancient Persian caravan techniques for insulating ice with wet felt, a California startup developed a biodegradable packaging material that keeps food cold for days without refrigeration. In Mongolia, herders facing climate change have revived traditional ice cellars called kudu to preserve livestock vaccines after watching archaeologists reconstruct them. The past isn't just informing the present, it's actively shaping our future. What emerges from these frozen time capsules is a profound respect for ancestral ingenuity. Where modern tools fail, ancient methods thrive not because they're primitive, but because they're perfectly adapted to their environments. When a Norwegian researcher finally succeeded in transporting ice blocks using only Bronze Age tools, his journal entry captured the essence of experimental archaeology. "We didn't master the ice today, the ice mastered us, teaching lessons its keepers learned millennia ago." The true value of these experiments lies not in proving what was possible, but in revealing how much we've forgotten and how much we still have to learn from those who moved mountains without metal. The scorching realities of climate change are forcing us to rethink one of modern life's most energy-intensive conveniences: artificial cooling. As temperatures soar and power grids strain, a quiet revolution is unfolding in laboratories and startups worldwide, where engineers are poring over ancient manuscripts and archaeological findings for solutions. The same techniques that kept ice solid in Persian deserts and Andean highlands are now being adapted for 21st century challenges, proving that sometimes the most cutting-edge innovation wears the patina of antiquity. Take the humble straw, once layered between ice blocks by Mughal traders crossing the Thar Desert. Researchers at the University of Cambridge recently discovered that compacted straws are value. A measure of insulation effectiveness rivals some modern synthetic foams when combined with clay binders. A startup in Arizona now produces straw clay panels for eco-friendly cold storage, reducing energy use by 60% compared to conventional refrigeration. Meanwhile, in India's Rajasthan desert, farmers have revived thousand-year-old techniques by burying earthen pots filled with water in straw-lined pits. As water evaporates through the porous clay, it chills the interior to near-freezing temperatures, perfect for preserving vegetables without electricity. This isn't just nostalgia, it's thermodynamics refined through generations of observation. Evaporative cooling, perfected by Egyptian traders who hung ice-filled amphorae in courtyards, is experiencing a high-tech renaissance. Architects in Dubai's scorching Business Bay district have installed wind towers modeled after Persian yakchuls on rooftops. These structures channel breezes over water-saturated pads, cooling air naturally before it circulates through buildings. The result: office spaces that stay comfortable without energy-guzzling AC units. Even NASA has taken notice. Their Mars habitat prototypes feature clay cooling systems inspired by ancient Mesopotamian designs, where evaporation through porous walls creates stable indoor climates in extreme environments. The real breakthrough lies in hybrid systems that marry old and new. A Swiss company now manufactures refrigeration units that use zinc plates, a modern conductive material, paired with traditional wool insulation, achieving efficiency levels that surpass conventional compressors. In Japan, engineers have redesigned data center cooling based on Edo period icehouse ventilation, slashing energy consumption by half. These aren't steps backward, they're leaps forward, using ancestral wisdom to solve problems that stumped contemporary engineers. Perhaps the most promising development comes from the world of materials science. The Incas mixed volcanic pumice into storage walls to regulate temperatures, a technique that seemed primitive until researchers at MIT analyzed its microstructure. The pumice's labyrinthine air pockets turned out to be ideal for slowing heat transfer. Today, companies are 3D printing insulation materials that mimic this ancient geometry, creating ultra-efficient barriers without toxic foams. Similarly, Mongolian herders' use of felted wool for ice transport has inspired biodegradable shipping containers that keep medical supplies cold for days, no ice packs required. The implications stretch far beyond refrigeration. Urban planners are studying how ancient ice routes chosen for their shade and natural thermal buffers could inform green city design. In Barcelona, a new park's pathways follow the same zigzag patterns Persian traders used to minimize sun exposure for their caravans, reducing the urban heat island effect. Even agriculture is benefiting. California wineries now store grapes in straw-packed chambers modeled after Armenian ice caves, preserving freshness without carbon-heavy refrigeration. What makes these ancient methods so relevant isn't just their sustainability, but their resilience. When Hurricane Maria knocked out Puerto Rico's power grid, hospitals using clay pot coolers kept vaccines viable while electric freezers failed. In remote Alaskan villages, traditional underground ice cellars now preserve food as permafrost thaws and modern freezers become unreliable. This isn't about rejecting technology, it's about building systems that work when technology falters. The future of cooling might just resemble its past, decentralized, adaptable, and deeply attuned to nature's rhythms. From smart buildings breathing through wind catchers to vaccine logistics relying on evaporative textiles, the frozen legacy of our ancestors is thawing into new life. As we face a hotter world, their greatest lesson whispers through time that true progress doesn't always mean inventing anew, but remembering what already worked and refining it for the challenges ahead. The lost engineers of the ancient ice trade didn't just move frozen water, they moved the boundaries of what we thought possible. With no metal tools, no fossil fuels, and no modern science to guide them, they built an empire of cold that stretched across continents and centuries. Their legacy isn't just a curiosity of history, it's a masterclass in human ingenuity, proving that innovation thrives not in spite of constraints, but because of them. Think about what they achieved. They transformed straw and mud into insulation more effective than some modern materials. They turned gravity and evaporation into natural refrigeration systems. They mapped hidden thermal currents in the earth and sky, harnessing them to keep ice solid under desert suns. These weren't lucky accidents, they were deliberate, hard-won victories against nature's limits. And they did it all with materials that returned to the earth without a trace, leaving behind no pollution, no waste, just whispers of their brilliance in old texts and crumbling ice houses. Today, as we grapple with the consequences of our energy-hungry world, melting glaciers, buckling power grids, and rising temperatures, their solutions feel less like relics and more like revelations. What if the path forward isn't just more advanced technology, but smarter, humbler design? The Persian yakchul, the Andean ice stair, the Himalayan felt wrap, these weren't just tools. They were philosophies born from observing how cold moves, how heat lingers, and how nature already holds the answers if we're willing to listen. There's a quiet rebellion growing in labs and workshops today where engineers are asking, what did they know that we've forgotten? Architects in the Middle East are reviving wind catcher designs to cool buildings without AC. Climate scientists study Inca irrigation systems to manage water scarcity. Even space agencies look to ancient evaporative cooling for off-grid solutions on Mars. The past isn't just history, it's a toolkit for survival. But the real lesson isn't just technical, it's about mindset. Those ancient engineers didn't conquer nature, they collaborated with it. They worked within limits, not against them. That's the gift they leave us, not just methods, but a way of thinking. In a world obsessed with bigger, faster, stronger, their legacy whispers another way: smarter, kinder, more resilient. So the next time you drop a cube into your drink, take a second to marvel at it. That simple piece of ice carries an epic story, one of cliffside caravans and midnight harvests, of inventors whose names we'll never know but whose ideas still shape our world. Their genius wasn't frozen in time. It's waiting for us to rediscover it. If this journey through the frost-laden corridors of history sparked your curiosity, let us know in the comments what ancient innovation amazes you most. And if you want more deep dives into forgotten brilliance, don't forget to like, subscribe, and hit that notification bell. The past is full of surprises, and we're just getting started. Until next time, keep exploring.